Hello guys and welcome back to another video. In today's video, we're going to introduce the concept of functions, explore their domain and range, and learn how to work with function notation. Let's dive right in. In a function, we have three sections pretty much. We have our input, which is our x. We have our function or our machine, which is noted like so. And we have our output, which is our y value. A function is basically like a machine that takes an input, performs a specific operation, and produces an output based on the specific input. So for every input, there's exactly one output. For example, if we have f of x is equal to 2x plus 3, this is not an equation, as f of x is not really a value. So it's not like if you equal this to 0. This is not the same, right? It's just a function. Let's consider this function, and let's put an input. Let's say this is f of 2. Therefore, this means that the value of x is 2. So this would be 2 times 2 plus 3. 4 plus 3, 7. That is the value of f2 for this particular function. Of course, it depends on the input. If we do f of 0, then this is 2 times 0, 0 plus 3, so 3. If we do f of 1, then this is 2 times 1, 2, plus 3, 5. If we do f of minus 8, then this is 2 times minus 8, minus 16, plus 3, minus 15, and so on. So depending on your input, depending on your x, you will obtain a different value for your function, for your output, your y. Now let's focus on characteristics of functions. One of these characteristics is its domain. The domain of a function is the set of all possible input values, all the possible values for x. For example, if we have a normal linear equation, like f of x is equal to 2x plus 3, as we saw before, any input of x will give you an output. But, for example, the domain of this function, square root of x, is not all values, as a square root cannot be negative. So x is always positive. So the domain for our second function, for this function right here, for f of x, is equal to all real, which is noted like so, positive numbers. Basically, from 0 to infinity, all real positive numbers, including 0, as we cannot have, for example, f of minus 1. This will not work as it is a square root. Typically, the domain is all real numbers if we have the domain is all real numbers if we have, for example, a quadratic equation or a linear equation. But, for example, if we have an equation like so, f of x is equal to 9x minus 2 divided by 3 minus x. In this case, our x cannot be 3, as we know that this would give us 3 minus 3, which is 0, and we cannot have a denominator of 0. This would be an undetermination. So, to do this, we can say that domain, DOM, you can also simplify it like so, of f of x is equal to, let's put it here, negative infinity, because it can also be a negative number, a fraction, doesn't matter if it's negative or positive in the denominator, minus infinity to 3, not including. If it were including, it would be square brackets, and normal parenthesis is not including, union 3, not including infinity, or all real numbers except for 3. These are both two notations that are both correct, and you can use to explain the domain of this particular function. Now with the range can be a bit more complicated to understand, but I'll try my best to explain it as well as I can. The range of a function is basically the set of all possible output values. The domain was the input values, the range is the output values or the y values that result from plugging in the input, the x values from the domain. So let's look at an example so it is easier to understand. If we have f of x is equal to 1 over x minus 2, we have seen before that the domain of this would be all real numbers except for 2, as 2 minus 2 is 0, and we cannot have a 0 in the denominator. But also, the range cannot be 0. The y value will never be 0, as if we do 1 divided by x minus 2 equals to 0, all we get is we pass this to the other side, 1 is equal to 0, which is obviously not true. So the range for this function can also not be 0. You would say this like so. Range f of x is equal to all real numbers except for 0. So, while the domain is looking at all the x values, like so, the range is looking at all the y values, like so. And this is where we introduce the x-axis and the y-axis of a graph. Let's practice with the other example that we have seen for domain. F of x is equal to square root of x. We know that the domain of this is only positive numbers. It can only be 0 to infinity. But the range of this is also only positive numbers, as no number, square root, will give you a negative number. Square root of 9, 3. Square root of 4, 2. Square root of 100, 10. None of those numbers will give you an output of a negative number. So you can also say that the range of f of x is equal to all positive real numbers. Thank you for watching. That will be all for today's video. And don't worry that in next videos, we'll be also looking at domain and range, and we'll be finding those of different functions.